Upgrading a detector at Fermilab is a very complex task. First, the physicists must determine what they want to accomplish and improve. Then the design is reviewed and approved. Finally, the task of actually making the detector, taking it from an idea to a reality, must be completed. One of the engineers assigned to the task of upgrading the CDF detector is Rafael Silva.
The job was to replace the existing drift chamber at CDF, the CTC, with the new one, the COT. That's a challenge because it had to meet the geometrical constraints of the old detector and include all the new features that the physicists wanted.
The engineering of the detector was handled by doing a finite element analysis of the components of the detector. This helps assure that the components will be able to handle the loads and stresses put on them.
This was a major job because of the complexity of the features of the plate. It was a big plate. The finite element analysis requires that if you don't analyze the whole piece, that you get a piece that's repeatable, you know, a segment that's symmetric or something. And the part of the plate that was symmetric or repeatable, it was a pretty big chunk. So you had to make a model, you know, of it, like like a CAD drawing with a lot of features. And this was pretty complex. We actually didn't have computer power enough to be able to do it here the way we would like. So there was a little bit of guesswork involved, but it turned out okay.
The next challenge was to find vendors who could fabricate the components as they were designed. Multiple vendors were chosen based on their expertise in the necessary manufacturing processes, along with their willingness to do the job.
We normally have to ask the vendors to provide us with one-of-a-kind and the resources they normally have to use to be able to meet our demands in tolerance and materials and everything are very stringent. So in the case of the end plate, we only had 3 companies that actually gave us bids. And the reason is because no one's, like the same company that made the plates for us, they didn't want to stop making parts for Boeing, you know, getting a new setup just to make those plates for us. That's something very, it's a challenge for procurement.
The vendors faced the challenge. They worked with their expertise to help make some very complex components. It wasn't always easy. Along the way, many other problems surfaced. As an example,
the end plate actually deforms vertically because you remove so much material that actually, you know, it squishes. This is another problem we found out during the process of fabrication. So it was very challenging.
Finally, the components were able to be assembled at Fermilab. New fabrication techniques were employed to meet the time constraints put on the upgrade program. The detector had to be assembled vertically and then flipped to a horizontal position to complete the installation of 75,000 wires.
The COT right now, it's at a clean room at IB4. It's being still what I call stuffed. The sense planes and field planes are being put in. We should still be working on this for another couple of months, and probably at the beginning of next year we'll be moving the COT to B0 and installing it. And that's going to be another interesting thing. So I hope I will be there and everything's going to go smoothly.
During the final assembly stages of the new central outer tracker, the existing central tracking chamber and other components had to be removed to prepare the detector to receive the new upgrades.
The removal of the VTX and the CTC, the main priority was not to harm what was around it, the cryostat, because we're going to reuse it, pretty much. So we had to be careful with that. Second, the components itself that we were extracting, the CTC, the VTX, and the SVX prime, there were uses for them. So the CTC, the latest on the CTC is that it's probably going to become a museum piece. The VTX and the SVX prime are going to go to the Smithsonian Museum, so they're going to be definitely in a museum. You can be a carpenter, I think, or whatever. And it's very nice to have the feeling of starting a design from nothing and having the thing actually built and working. and see this whole process from beginning to end. To me, it's extremely satisfying. I'm proud of the work we've done, and this was by no means a feat that was achieved only by myself. There were more than 50 people involved, a lot of engineers, people from other institutions like Berkeley and Argonne Laboratory and other places. So it is very satisfying to see all this work coming together, and producing a detector that pretty much achieves the results that were expected, mechanically speaking at least.